the number of neutrons with the sea surface temperature in recent times, where people had thermometers. Crazy organizations like the U.S. Navy and guys like that keep very accurate records of the sea surface temperature going back hundreds of years. And they look at the old instruments, the old thermometers. The British Navy had these guys, and they're dead on. They're still very accurate instruments. So then you figure, well, if we're getting it right now, then you can infer back thousands of years by counting layers of ice in the ice cores. And this, my friends, is what we call scientific evidence. Now, what would you be doing if you weren't here tonight? That's right, you'd be watching CSI. I know. The problem, of course, would be which one. CSI Poughkeepsie, CSI CSI Rome. No, not that Rome. No, the one in New York. But anyway, when you find the fiber of the carpet in the guy's shoe with the blood from the murder, he was in the room, okay? He was the perp. All right. When you find the neutrons in the ice, in the bubbles in the ice, then you know that that was the temperature of the sea surface way back in the day. That's it. End of story. Okay, so I'm always impressed and amazed by people who choose to ignore this. It is astonishing. Then these people count tree rings. Warm season, cold season. They look at trees that fell down. They look at natural events that are well recorded, comparing the width of the tree rings. This is accessible to analysis. Here's a picture I took of Greenland, and if you look carefully, I was flying. Actually, I was in a plane.
My battery.
Oh yeah, I'm good. Anyway, you look up there. There's an ice dam that gave way. I just happened to look down at that moment, and fresh water was flowing into the sea. This is in the wintertime, and in February. You would not expect this. This is a new thing. The world's getting warmer. If you've never done this, I strongly encourage you to do this. Get a couple pitchers of water and put some ink in them. And what you can do, if you're careful, you can get a syringe like people use in medicine, or you can, if you have a really nice graduated cylinder. Chemistry club? Graduated cylinder? Yes! Yes! My grandfather was an organic chemist, so right on. You can measure ink very precisely, or precisely enough, and you can compare and contrast. Here's 250 parts per million of ink, which would be then the amount of carbon dioxide in the world in a year. The year everybody loves is 1750. That's about the year James Watt invented the steam engine. He did what? That's right. He invented the steam engine. That's just still funny to me. All right. Right now, as the last reckoning, worldwide, we're at 389 parts per million. Maybe it's 390, 388, whatever, worldwide. Parts per million of carbon dioxide. And you say, Bill, science guy, parts per million, who cares? That's not even, let's see, 400 parts per million, that's not even a percent. Dude, that's not even a tenth of a, that's 0.04%. How could that affect me? Well, intuitively, if that dark color were something other than happy ink, you might not be inclined to drink it, for one thing. If it's that much carbon dioxide and you're a green plant. By the way, a study was done on poison ivy. You might know that poison ivy thrives as carbon dioxide goes up. That's great news. Yeah. If you're a green plant, you might think, oh, that's great stuff. But if you are a human trying to conduct your civilization, you might be concerned because the world's getting warmer and carbon dioxide is a big part of that. The problem we have is this next thing. When I was a young man, I went to the World's Fair in New York City. And there was New York City, way to go! Are the Yankees going to buy that picture? Can we just let them play? Can we just... Really sorry the Yankees did. Yeah, really sorry. Heartbroken. Sorry, guys. You live out there enough. All right. Sorry, I'm going to get into that. Now, hold that. Now, I went to New York City in 1965, and they had a tote board, or a total board, of the world's population. And my father and I were very disappointed. We missed it changing from 2,999,999,999 to 3 billion. It had happened just a few hours before we got there. Now, my father's the guy that pulls the car over and starts taking pictures of the odometer. It changes from 99,000, there's a word for this, 99,000 miles to 100,000 miles. He took pictures of it. Hello, officer, what? No, I was just taking pictures of the odometer. And we missed it. Changed to 3 billion. I was sitting in the airport this afternoon and I captured this from the Kooky Poodwaddle. 6.8 billion people. And you guys were alive for this. You were alive for, you'll see 7 billion, like it seems like by the weekend. You guys, by the end of 2012, we'll have 7 billion, I guess before that. So there used to be 3 billion. When my father was a kid, there were 1.5 billion people on Earth. This is the problem. This is how we can change a climate for the skeptics. When you got an atmosphere that's so thin, and you got so many billion people running around trying to make a living, you end up changing the world's climate. Now, for example, the last 10 years are the 10 warmest years on record. And that's an Australian graph. This is Union of Concerned Scientists, which is mostly US based. And the last 10 years have been the warmest 10 years on record. And you may notice there was a hailstorm in New York yesterday. Not sleet, hail. Hail is a thunderstorm, summertime phenomenon. There have been many floods. There have been floods in Tennessee, in Oklahoma. There have been a tornado in Brooklyn. This is consistent with what would be expected from climate models if the world's getting warmer. I talked to Michael Mann, the guy who did the first hockey stick graph. He's a big ice core guy, where the world goes along about this temperature, then it gets warm real fast. Anyway, he said he can't show that these storms are global warming right now. But in 3 years, he'll be able to look back and prove it. Furthermore, this year, 2010, will be the warmest of the last 11 years. So the world is getting warmer, and you'll see this number, 0.69 Celsius, which doesn't sound like much, but it's a lot. When the world gets warmed by just that much, it's a bad thing. You may have seen pictures like this. I don't know why the guy would park the truck there. It didn't work out. And then the polar bear on his iceberg, it's very sad. Mr. Polar Bear, very sad. Then here's a projection of what will happen to South Florida if this big chunk of Antarctica breaks free. This part has Kennedy Space Flight Center in Miami and all that television that we know and love. There's a CSI there, I think. And all that stuff will kind of be underwater. Now, you can, if you'd like, run in circles screaming. The world's getting warmer. Oh my goodness, Bill Nye was here. I thought he was going to be funny and charming. But he went on and on about the world's getting warmer, and I gotta say, it kind of sucked. I know. But stay with me here just for a moment. So, if you go to New Orleans, here's a gas station that is gone. Katrina just swept it away. I mean, not a woman named Katrina, a hurricane. Swept it away. But 4 years later, these guys build a drugstore right there. And this is where people, where I live in Southern California, would say something like, dude, dude. It's right there. Here in New Orleans is one of the dikes that overflowed. It didn't overflow, it overtopped. Excuse me, Mr. Army Corps of Engineers, it overtopped. You mean the water went over? Yes, yeah, it flooded it. So they're building a house on stilts right there, and the water line is clear, you can see it. And everybody, let's say the dike was high enough when Katrina hit. Is it going to be high enough next time? This is where, I don't want to shock any of the young people, this is where someone might say to you, are you high? The thing is, we don't have to do it this way. We can do better than this. This is where I want you to, dare I say it, change the world. A few years ago, I had the use of the EV1, the General Motors, yes, right on, the electric vehicle one. General Motors, for a little while, chose to call this car the Impact. That's brilliant. That's brilliant. The crash, the wreck. Now, you can hate cars. You can hate people who like cars. You can hate everything. You are a miserable, everything hater person. Fine. This car was sexy. Bitter and miserable as you are, this car was cool. All right, well, let me just tell you what happened. I had it, I leased it. The man would not sell it to me. The man comes and takes it back on this trailer. And then the man takes all the cars to Phoenix, right outside of Phoenix, and crushes them. I know, yes, whoever you are. I heard this, yes. It was literally, to those of us who had the cars, it was incredible. But like, dude. So they crushed them because they didn't believe in the technology. Now you might see the movie Who Killed the Electric Car, whatever, fingers are pointed, but some middle management suck-up at General Motors didn't believe in it. And so this would have been forward-thinking breakthrough technology, came from the late 1990s, early 2000s, the Audis, the millennials, and they didn't believe in it, so it went away. Wait, there's more. Okay, here's the Chevy Suburban, 12 miles to the gallon.
That's a lot, right?
This is the Prius, 44 miles to the gallon. Now, what I'm saying to you is if we had every vehicle on the road get 4 times the mileage that they do now, it would change the world. Now, let me talk to you ever so briefly about the Prius. The Prius is made of the same stuff as a car. It is a car. It is made of car stuff. It is not made of unobtainium or whatever. It's just a car. It has wheels, tires, brakes. I have a CD player, if you remember those. I have an aftermarket device I can plug in my iPod, yes. I can do all that, party on. It has a windshield, it's got all that stuff. And this car really is now not that advanced technology. It's pretty good. 44 miles to the gallon, using batteries to recover some of the energy that you normally throw away. There's the places you throw it away are at the stop sign, stoplights, so the engine's idling, nothing's happening. And then when you slow down, you can recover some of that energy, regenerate, regen, as we said, regen. We're so cool. And then the other thing is, cars have to be built big enough, with engines big enough, to merge onto the freeway. This is a big limitation in automotive. I don't want to make all of you guys into a bunch of gearheads, automobile designers, but just you're familiar with it. You try to pull onto the freeway, you have to accelerate. Let me tell you, the EV1, 10 years ago, 0 to 50, my gearhead friends, 0 to 80 kilometers an hour, 0 to 50 miles an hour, 2.8 seconds. It was cool, and I can tell you, gentlemen, women liked it. I can tell you. So the Prius, by the way, not that I'm not working for Toyota, but 0 to 20, 0 to 15, if you're leaving the stoplight, the Prius is a very high performance car. It's quite wacky. So the thing is, why aren't we doing that? And the answer is we kind of are. You guys are living at the moment of moments. You guys are being graduated from college at the moment in history when you will be able to, dare I say it, change the world! Now, here's the Golden Gate Bridge. Let me rephrase it. This is a picture of the Golden Gate Bridge. If we had the Golden Gate Bridge here, well, your eye would go right to it. All right. So, the Golden Gate Bridge is made of steel. It was the state of the art back in the day. And yes, if you've never been there, there is a crew that paints it from one end to the other, and then they go back and start again. They do. Full-time painting. Oh, wow. Yes. So it's made of steel. And it works great. But I had the great privilege of interviewing a guy named Richard Smalley. And unlike many of us in this room, he had a Nobel Prize. And he got the Nobel Prize for discovering this molecule that he called the Buckminster fullerene. Now, if you've never heard of him, Buckminster Fuller was this architect who invented or promoted or did a bunch of very compelling analysis of the geodesic dome. The triangle, the dome is made of triangles. It's a very efficient structure from a material standpoint. You don't need much metal or fiberglass or unobtainium to make a big unsupported dome. In fact, Buckminster Fuller proposed that we build these things so big they would float on the atmosphere like a ship. Crazy. Just what I want to do is float on the atmosphere. It might be fun. Anyway. So Rick Smalley got a message from his buddies he was a chemist from the astronomy department, and they had, through their telescopes, discovered a compound or a molecule or something, obtainium, in space that they couldn't identify. It had a spectrum. The light passing through it changed the frequent or the absorbed wavelengths of light. They couldn't figure it out. So Rick Smalley told the story to me, and he must have told it 1,000 times, but he was really good at it. He told the story. He was in bed at 3 in the morning. He woke up and figured it out. He stayed up all night cutting out triangles, pentagons and hexagons, and he figured out that this thing is a sphere. This molecule of carbon is a sphere with 60 carbon atoms, and it's the same pattern as a conventional soccer ball, white and black soccer ball with white hexagons and black pentagons, hexagon, pentagon. And so that's a picture of a model of it in the foreground. And then Rick Smalley's dream was that the thing would be self-organizing, that you'd be able to somehow pull the sphere apart and it would form these tubes, when the term everybody loves is nanotubes, a billionths of a meter tube. And this stuff, if it existed in long lengths, would be 10,000 times stronger than steel. I'm sorry, Bill, I thought you said I did. I said 10,000 times stronger than steel, and would weigh a sixth as much. We can grow these, I say we, you guys, engineering students, can grow them 50 nanometers, 30 nanometers. But what if we could grow them a meter, a football field, 100 meters, a kilometer, half a mile? It would change the world. Everything we think of as being made of steel would be made of carbon. Yes, I remember we had coffee mugs. They were made of stone. We had to lift them with our arms. Oh, you did yes, everything. We put liquids in them, exercise, and various student activities. paraphrase. It would change the world. And you guys may be able to figure it out. Now, even